to solve an example related more to radicals and how to deal with them. So we are given A, B, and C, and here are the questions that we want to answer. So if you want, pause the video to write the questions on your notebook. So starting with part A, compare A and B. So here is A, here is B, and we want to compare it, which is greater, which is smaller, or are they equal? I don't know. So in order to compare them, first of all, they should be written in their simplest form. And we notice that they are not written in their simplest form because 18, it may be factorized, and 12, it may be factorized. So let's start with A, which is equals to radical 2 plus radical 18. So 18, radical 2 is a prime number, so we cannot do factorization for 2, but for 18 we can. So how do we factorize, or how do we decompose it? Of course, by using a prime factorization. So if you know it directly, you can write it. Or if it is a bigger number, so I'm giving you the way how to do it. So we write the prime factorization. So we divide by prime numbers in order. So divide by 2, which is 9. 2 is not, the 9 is not divisible by 2 anymore. So now we divide by 3. So the answer is this 3, and by 3, 1. So 18 is 2 times 3 squared. Thus we write, instead of 18, we remove it and write this answer, 2 times 3 squared. And now, as we know, square will be cancelled with the radical only for 3, for 2 no. And 3 will be outside the radical. So radical 2 plus 3 radical 2. And as they are the same radical, radical 2 and radical 2, so this is 1 radical 2 plus a 3 radical 2. So 1 radical 2 plus a 3 radical 2, it will be 4 radical 2. So this is A. And now we want to do the same steps for B. So B equals to radical 3 plus radical 12. And 12 also we do the prime factorization of 12, or if you know it from the multiplication tables, you can write it directly. I'm writing all the steps. So 6, and it is divisible by 2, so by 2 it is 3. Now it's not divisible by 2, so we divide by 3, the answer is 1. So 12 is 2 squared times 3, so radical 3 times 2 squared times 3, which is equals radical 3, I'm sorry, this is plus. Okay, so radical 3 plus 2 radical 3, it is 1 radical 3 plus 2 radical 3, which will be 3 radical 3. So here we got B, and we got A, and now we should compare. Now after I written A and B in their simplest form, I want to compare A and B. But because A and B are in the form of an irrational number, thus I cannot compare them directly. I need to find A squared and B squared in order to get rid of the radical, and then I can compare them. If you have questions regarding this idea, I have explained it before in a video, so I will put a link in the description below to that video, so you can go back if you haven't understand this idea fully. Okay. So A squared is equals to 4 radical 2 all square. So square is for 4 and for radical 2. Do not forget that. So 4 squared radical 2 squared. Like I distribute the power 2 for both of them. And 4 squared is 16 times 2. And our answer will be 2 times 6, 12, and 2, 32. Now, B squared is 3 radical 3. All squared. Then so we will distribute the power 2 for 3 and for radical, and I can do that because I have multiplication between them. So 3 power 2 times radical 3 power 2, and we will obtain 9 times 3, which is 27. So here is A squared, and here is B squared. Then who is greater? A squared is greater than B squared. Therefore, A is greater than B. And that is because A and B are positive numbers. Okay, whereas if A and B are negative numbers and A squared is greater than B squared, then A is less than B. So I repeat, I have explained that fully in a video, and you can find it in the description below. Moving on to part 2, find the value of A squared plus 2A, B squared plus A squared minus 2BA. So we want to find B squared plus A squared minus 2BA. So what may come across our head is that we will find the value of B and substitute it here, and then we will make square and we will distribute the square also for A, and then a BA we will multiply them, and then maybe we will struggle with this big radical and how can we get rid of that. Instead, I have another idea. So look carefully, B squared plus A squared minus 2BA. This expression is similar to something that we know, which is similar to A squared plus 2AB plus B squared, right? But it's in different order, but it is the same. So A squared 2AB plus or minus, it's both work. So here it is a minus. So minus 2AB plus B squared. And this expression is the expanded form of A plus B all, if we have a minus, for A minus B all squared, and this is for A plus B all squared. So instead of this expression, I can write A minus B all squared. And why do I prefer that way? Because instead of those, if I write A minus B all square, square and the radical will be cancelled, and then I don't have to struggle with the radical because it's cancelled, and then just I need to solve A minus B. Okay? So that's what we are going to do. So here we will write the radical. So instead of this one, B squared plus AB plus A squared minus 2AB, we will write A minus B all squared. And then you see this square is cancelled with, looks like a 4. So this power 2 will be cancelled with the radical, and we got A minus B. And this is a easy question. A minus B, we put A for radical 2 minus 3 radical 3. Okay, let's see if we can do anything for this expression. So this is radical 2, this is radical 3. Can I simplify it more? No, because this is belong to the groups of radical 2 and this is to the group of radical 3, so I cannot combine them, I cannot add them or subtract them. So this is our final answer, 4 radical 2 minus 3 radical 3. Now moving on to part 3, rationalize C. So rationalize, it means that we should, this is C, we should remove from the denominator the radical. In fact, it is rationalize the denominator of C. So we should remove the radical from the denominator. And how do we do that? We should multiply by the conjugate of the denominator. And I need to remember, I need to refresh your memory that whenever we have in the denominator, for example, radical 2, okay? So the conjugate of radical 2, in order to get rid of the radical in radical 2, we just multiply by radical 2 and radical 2. So radical 2 times radical 2, it will be radical 2 squared, and then done, the radical is it's gone. So if we have, for example, 2 radical 2 or 3 radical 2, okay, here we also can multiply only by radical 2, not by 3 radical 2. No need to multiply by 3 radical 2. So if we multiply by radical 2, it will be 3 times 1, it's 3, and radical 2 times radical 2, so it will be 3 radical 2 squared, and it will be 3 times 2, so our answer will be 6 in the denominator and whatever numbers in the numerator. So even if we have like a radical without the 3, okay, we will multiply by this radical, and if we have a number and then a radical, I will stick to multiply by just a radical and do not multiply by 3 radical because you just have bigger numbers. Okay, if you multiply just by radical, you will get there. Now, if you have plus or minus, see here you do not have plus or minus, okay? They are two numbers multiplied by each other, 3 radical 2. But if you have numbers that we have plus or minus, so the conjugate of that is that you look at the sign in between these two numbers and flip it. So the conjugate of radical 5 plus radical 3, radical 5 minus radical 3, okay? And of course you multiply in the numerator by the same number. So I multiply in the denominator by, I look at the denominator, so these two numbers, I look at the sign here and I flip it. If it is a plus, I write minus. If it is minus, I write a plus, okay? And the number I multiply it here, the same I multiply it here in the numerator. Now I should find my answers. So look please carefully at radical 5 plus radical 3 times radical 5 minus radical 3. So you are multiplying this by this and this by this. Radical 5 plus radical 3, radical 5 minus radical 3. This should remind us of an identity that we know, which says that a plus b into a minus b, it's equals to a squared minus b squared. Then this is a plus b, a minus b, it should equals to a squared minus b squared. Then radical 5 squared minus radical 3 squared. And every time it will look exactly like this expression because we are taking a and b the same and just we are flipping the sign. So always it will be this identity. But in the numerator, we should expand. So we expand using the arrows. So 3 radical 5 we multiplied by the first and the second term in the second parenthesis. Also 5 radical 3 we multiplied by the first and the second term. So let's start by 3 radical 5. So 3 radical 5, if we multiply it by the first term, remember, of course I should remind you that if we want to multiply a radical b times c radical d, so multiply the number, the outer numbers by the outer numbers here, a times c and b times d under the radical. So ac, and we have radical, those numbers under the radicals, I multiply them by each other. So here, if I have no number here, then I have 1. So 3 times 1, it's a 3. And under the radical, I have radical 5 times radical 5, which is radical 5 squared. I write it radical 5 squared and not 25 in order to cancel power 2 with the radical. And now here we comes. So 3 times this, we no number outside, but we have minus. So it is minus 1. 3 times minus 1, it will be minus 3. And the numbers inside the radicals is radical 5 times radical 3, it's radical 15. So we have finished of the first two arrows. And now we are going to move on to multiply 5 radical 3 by the first and the second term. Now, 5 radical 3 times radical 5. The outer numbers together, 5 times 1, it will be 5 radical 3 times 5, 15. And the outer numbers of these two together, 5 times minus 1, minus 5, and radical 3, the inside the numbers I multiply by them by each other, so 3 squared. Okay, and now I got and now So I have couple of radicals in order to get rid of them. So this radical, I will get rid of it, this radical, and this radical. So whenever I get rid of the radical, this number and this number will be multiplied together. So 3 times 5, it will be 15. Let's see. Okay, let's solve these together. So minus 3 radical 15 plus 5 radical 15. Both of them are radical 15. So they belong to the radical 15 group, let's say. So minus 3 radical 15 plus 5 radical 15. Minus 3 plus 5, different signs. The sign of the greatest is a plus. And we subtract them. 5 minus 3, 2 radical 15. And whenever the radical is removed, I should multiply 3 times negative 5. It will be negative 15. And in the denominator, 5 minus 3. Now, you can see that minus 15 and plus 15. Okay, great. So we have 2 radical 15 over 5 minus 3 over 2. Good. So we have 2 and 2 can be simplified together. So our answer is radical 15. Part 4, verify that c squared minus radical 45 over 5 is a natural number. How can we verify this thing? So we just calculate it and see if the answer is a natural number or no. So let's see. So c squared minus radical 45 over radical 5. So whenever they ask us verify that or show that, we just work and see if the answer is correct. And when they say for us verify that it is a natural number, then for sure it will be a natural number. They're not asking us if yes or no. They are telling me prove or show me that it is a natural number. So of course the answer is a natural number. And if it is not a natural number, then we have some wrong calculations. So c squared, so c, we have obtained our answer, which is radical 15. So radical 15 power 2 minus radical 45 over radical 5. And now the squared will be gone with the radical, so 15 minus. Look here, radical 45 over radical 5. We should remember some important rule regarding the radicals, that radical a over b is the same as radical a over radical b. So and the same, radical a over radical b, we can write it as radical, a big radical, 45 over 5. And 45 over 5, 15, I'm copying it the same. 45 over 5, it is 9. So radical 9. And radical, and you know that 9 is a 3 squared. So 15 minus radical 3 squared. Square will be gone with the radical. 15 minus 3, it's equals to 12. Yes, it is a natural number. So we say that finally, we say then c squared minus radical 45 over 5 is a natural number.